Greetings, welcome to today's lecture. So, today we are going to have a brief and broad overview of electric powertrains. So, we have looked at in great detail about conventional IC engine based powertrains, how IC engines work, what are their characteristics, why do they need a multi-speed gearbox. We have also learned how do we calculate the gear ratios of a multi-speed gearbox based on certain vehicle performance requirements. So, those are topics that we have already discussed in detail. So, in today's lecture, we are just going to learn from a powertrain's perspective, what are the features of an electrified powertrain? What do we mean by an electrified powertrain? One, where the traction to drive the wheels is provided by an electric motor as opposed to an internal combustion engine. In fact, if you look back at the history of electric vehicle technology is not new, but interest in electric vehicle technology has essentially increased greatly in the recent years due to multiple reasons. Main among them being environmental concerns. We looked at engine emissions, right. So, we want to reduce IC engine based emissions, and that is also becoming serious with the increasing number of road vehicles. So, emissions are a concern, the corresponding environmental impact is also a concern. So, given those concerns, development activities into electric vehicles and hybrid electric vehicles has accelerated in the recent years. And in today's class, we are going to only look at the powertrain perspective. So, an electric vehicle today, needs to be designed from scratch. It's not just simply about replacing the internal combustion engine and transmission by an electric motor drive. So, we need to look at various other aspects. So, there are a lot of aspects to it, because even the design of the suspension, the design of the other components like brake systems, also get affected by electrification of the powertrain. But in this lecture, we are only going to look at the critical features of an electric powertrain. Okay, so that's going to be the scope of this particular lecture. So, if you look at it from a powertrain's perspective, what are the benefits that we get vis-a-vis an internal combustion engine, right. So, in order to identify those benefits, please recall that an internal combustion engine typically has a lower efficiency, when compared to in its range of operation. Comparatively, an electric motor is going to have a higher range of operating efficiencies, okay, which is going to be a positive attribute from the perspective of energy consumption. So, lower efficiency of internal combustion engines is one motivating factor. Another motivating factor, behind an electric powertrain is the fact that there is a big gap between the torque speed characteristics of an engine vis-a-vis the ideal traction hyperbola, and that was the reason why we need a multi-speed gearbox to try and reduce that gap, right. So, larger gap of the internal combustion engines powertrain from the ideal traction hyperbola, right, or requirements, ideal traction requirements, and that implied we needed to use a multi-speed gearbox. So, the question is, what happens with an electric powertrain? Okay. So, before looking at the pure electric powertrain, let us understand the classes of various powertrain choices that are available and their configurations. So, let us look at what we can refer to as a classification of electrified powertrains. Okay. So, based on the components and used and their configurations, like one can essentially have a broad category of powertrains. So, if you look at this schematic, right. So, we have the conventional internal combustion engines, like which are gasoline engines and diesel engines, right, and the powertrain based upon them or something which we have already discussed. If we consider a pure electric powertrain, of course, the electric powertrain can be divided into two broad categories. What is called as a pure electric, that is only an electric motor drives the wheels, and we have what is called as an electric vehicle with a range extender. Okay, so we will shortly see what that is. Then we can have what are called as hybrids. So, what is a hybrid powertrain? A hybrid powertrain is powered by two or more prime movers. Okay. See, for example, an electric motor and an internal combustion engine, right. So, that is a hybrid powertrain. So, a hybrid electric powertrain or a hybrid electric vehicle has typically an electric motor and an internal combustion engine as the two prime movers, okay, driving the wheels. Then there are various configurations of this hybrid electric powertrain. Okay, we will shortly look at their configurations, what is called as a series hybrid, a parallel hybrid and a series parallel hybrid. Okay. So, one also has what is called as a plug-in hybrid, where the battery is also recharged by connecting to the electric grid, okay, in addition to other features that we will shortly see about the remaining hybrid configurations. Okay. So, the question then becomes, like what are the aspects or what are the characteristics of these various configurations, and under what scenarios and under what requirements would one choose these various configurations, right. To understand that, let us look at these configurations to begin with. So, let us consider a pure electric powertrain. Okay. So, what is a pure electric powertrain? If we look at a simple schematic of a pure electric powertrain, so it essentially has an electric motor driving the wheels, like through a transmission, like so, that is it. So, we can observe that there is an what is called as a traction motor. So, typically when the electric motor is utilized to provide the energy required for driving the vehicle, we refer to those motors as traction motors. So, we can observe that the battery is the energy source and that provides energy to the traction motor, and the traction motor then uses a mechanical transmission, right, and then drives the wheels. So, a few important characteristics of a pure electric vehicle is that, like, we do not use any fossil fuel, right. This implies that there is no tailpipe emission. So, that is an important feature, and we will shortly observe that electric motors can provide a higher torque at lower speeds and during starting. So, that is going to result in higher accelerations, okay, higher vehicle longitudinal accelerations. So, faster acceleration of the vehicle due to higher starting torque. So, that is another advantage. So, what are issues? So, such pure electrics are suitable for vehicles where the energy consumption is also low, so that like we can have a reasonable size of the battery, but however with increasing vehicle sizes we need to have a correspondingly larger energy source, which in this case is a battery. Okay, so there is a trade off like in having a pure electric vehicle for all classes of vehicles. Okay. So the main issues that one needs to consider is the range of the electric vehicle. So what do I mean by range? Range is the distance travelled between two successive charging cycles, right. We charge the battery completely and then we discharge it completely, like then what is the range, or what is the distance in kilometers or miles that the vehicle has travelled. Okay. So that is the range. So charging time is another issue that one needs to look at, and of course battery life and cost are other issues that people need to consider while choosing an pure electric. Okay. So to address a pure electric vehicle limitations, we have electric powertrains or electric vehicles with what are called as range extenders. So what is a range extender or a EV with a range extender? So here we can observe that in the wheels are still driven by the electric motor, like one could observe from the schematic that the electric motor still drives the wheel. So that is the traction motor. Okay. So the electric motor obtains its energy from the battery and that is used for driving the wheels as before. But the only difference now is that like the battery is also charged by using an engine through a generator. Okay. So the purpose of this engine like is essentially to charge a battery, and typically these engines like are not going to have as high rating as they would have if they were powering the vehicle. Okay. So they are downsized engines whose specific objective is only to power the or recharge the battery through the generator, and the way also they are controlled is, since their only task is to recharge the battery and not to drive the vehicle, they can be operated under conditions where the engine gives its peak efficiencies. Okay. So that like the energy is utilized properly, right. So that is an electric vehicle with a range extender. So essentially an engine driven generator recharges the battery when required. Okay. So consequently range is better when compared to the pure electric, okay, and recharging time is reduced. But what is the limitation? Here we can observe that due to the presence of an internal combustion engine, tailpipe emission is present, and of course the cost is more, right, when compared to a pure electric vehicle because of the presence of the engine and the generator. Okay. So the initial cost is more. So we have tailpipe emission here, okay, in the electric vehicle with a range extender. So consequently like one can also consider hybrid electric powertrains. Okay. Those are available options wherein like we try to match the positive aspects of both the internal combustion engine and the electric motor rather than using them separately, that is the idea. So if we look at various configurations of a hybrid electric vehicle, so the first one is what is called as a series hybrid powertrain. So what is a series hybrid powertrain or electric vehicle. So, we can observe from the schematic that in a series hybrid electric vehicle, typically abbreviated as SHEV. Okay. So, there is an engine which can do two things, right. It can drive the wheels through this traction motor when required, or it can recharge the battery when required, or do both, okay, depending on the scenario. Okay. So, that is the purpose of the engine. The engine does not drive the wheels directly. The traction motor is the one which drives the wheels through the transmission, okay. But the traction motor can get its energy either from the battery or from the internal combustion engine through the generator, okay. So, those are the critical aspects of the series hybrid electric vehicle. So, in a series hybrid electric vehicle, the electric motor or the traction motor drives the wheels. And the engine driven generator can charge the battery or power the electric motor, okay, or do both. Okay. So, that is the role of the engine driven generator. And if you look at other hybrid electric vehicle configurations, compared with other HEV configurations, okay. So, SHEV has a simpler transmission and controller. Okay. So, that is the one advantage, and also this is well suited for frequent start stop driving. So, like one that we encounter in urban traffic, right. So, essentially we stop at signals and then start, like there are traffic jams, like we need to stop the vehicle and then restart and so on, right. So, in those conditions this SHEV is relatively better, okay. So, there are a few limitations. So, one major limitation is the larger and heavier traction motor which is used, because please note that the vehicle is still driven by the traction motor. So, consequently the traction motor needs to be of sufficiently high rating to drive the vehicle, okay. So, that is an issue with a series hybrid electric vehicle, okay. So, now the next configuration that we would be looking at is what is called as the parallel hybrid electric vehicle. So, in the series hybrid electric vehicle, only the motor directly drives the wheel, okay. So, but in a parallel hybrid electric vehicle, both the motor and the internal combustion engine can be used to drive the wheels, okay. So, that is going to be one of the main attributes or features of the parallel hybrid electric vehicle. So, we can observe that in this vehicle both the engine and the traction motor can drive the wheels, okay, can power the wheels through this mechanical coupling system. So, that is an advantage. But compared to SHEV, obviously the initial cost and complexity are more, and the fact that the transmission also becomes a little bit complex than a SHEV, because it has to accommodate two different prime movers, okay. So, those are some features of a parallel hybrid electric vehicle. So, the wheels are driven by both the engine and the traction motor. Okay. So, one advantage is that of course, we need a smaller traction motor compared to a SHEV, right. So, we do not, because since the task of driving the vehicle is also shared by the engine, we need a smaller traction motor compared with SHEV, that is an advantage, and this can work well in cruising also relative to SHEV, right. And a limitation is a complex controller and transmission when compared with SHEV. So, of course, all these we are comparing with the other hybrid electric vehicle configuration, right. So, those are some features of a parallel hybrid electric vehicle. So, now if one wants to combine the features of both the series hybrid electric powertrain and the parallel hybrid, so then one obtains what is called as a series parallel hybrid electric vehicle, okay, what is abbreviated as SPHEV. Okay, so that's another configuration. So let's look at a simple schematic to understand what a series parallel hybrid electric vehicle is. So in the series parallel hybrid electric vehicle, we could observe that the engine drives the wheels, the motor also can be used to drive the wheels. But now we can immediately observe that there is one more attribute. The engine can also recharge the battery through a generator. Okay. So one can observe that in a certain sense it combines the desirable attributes of both a series hybrid powertrain and a parallel hybrid powertrain. So like in a parallel hybrid, the engine and the electric motor can drive the wheels. Like in a series hybrid, the engine can charge the battery through a generator. Okay. So the IC engine what to say, essentially can be used to drive the wheels directly and charge the battery. If you recall, in a series hybrid, the IC engine could drive only through the electric motor, okay, not directly, right. So that is a difference. Of course, this results in increased flexibility of operation. So we can have more modes of operation depending on the operating state of the vehicle, but however, it is extremely complex and expensive, right, among the hybrid electric vehicle configurations, obviously, alright. So those are some limitations of a series parallel hybrid electric vehicle. So these are the various hybrid electric vehicle configurations. Of course, electrics and hybrid electric vehicle configurations and some features associated with them. The next topic which I am going to discuss is about the electric powertrain. Okay. So let us now look at the electric powertrain, discuss some of its features relevant for powertrain application and perform some basic analysis. Okay. So that is going to be the objective. So if we look at an electric powertrain, there are some major systems, okay, like in an electric powertrain. So one is obviously about the propulsion using the electric motor. So this system has traction motor, the transmission, the driven wheels, okay, and the corresponding power electronics and controllers, right, as its components. Okay, that is what is called as an electric motor propulsion system, and we have the energy source system. So, the energy source essentially consists of the energy storage, let us say in the form of batteries, right, and then we have an energy management unit which regulates the energy supply to the motor system, and then like we have also components for recharging and refueling, right, the energy source. Okay. So, those are important requirements, okay, important components, okay, of an energy source. So, by and large, you know, like we are going to be using batteries, but there are other choices like an ultra capacitor, fuel cell to power these powertrains also.